There we go. I think we are recording. We are. Thank you. Right. Okay. Yeah. Good afternoon, everybody, and welcome to the Welsh Azure Use Group April edition on the 16th of April. Um, let's kick things off. So, yeah, big warm welcome from myself and Matt. We are the last remaining organisers of the user group. So, thank you all for joining and welcome. If you've got any ideas or want to speak at the event or want to take part, do anything with the event that you think might be useful, please feel free to add us on LinkedIn and reach out to us and say hello. A couple of housekeeping rules just to quickly get through. Please, everybody, do be courteous to each other. Should go without saying, but there are no silly questions here. We're all here to learn. So please do stay on mute unless one of the speakers asks you to come off mute and use the chat window that you'll have access to ask any questions and just take part. Just, obviously be a little bit be engaged, join in with the chat and help each other with any questions you might have. Stick around for the quiz. It'll be after Colin's discussion, probably around about 8:15, something like that. So in about an hour and a half, hour and 40 minutes. But most importantly, please, everybody, be interactive and enjoy the session. So on that note, we have, as always, we seem to get the pick of the bunch with the speakers at this user group all the time. So we've got another two fantastic speakers for you this month. We're going to kick things off with Owain, who's going to talk to us around how we build self-hosted AI application using Kubernetes and KAITO. So looking forward to that and some intriguing stories that Owain's going to impart with us on that one as well, no doubt. And then after Owain's talk, we've got Colin joining us. Really interesting area, actually. I've been working personally with a customer of mine at the moment. So looking at Azure communication services and looking at that SMTP Relay component. So really intrigued as to what Colin's going to take us through there. So stick around for Colin's chat a little bit later as well. Timings wise, I'll stop my ramble in about 5 minutes or so, just a few bits and pieces more to get through. Be kicking off with Owain in about 10 minutes or so, and then Colin about 45 minutes afterwards. And as always, there are gift cards available for the prize winners tonight as well. Um, yeah, okay. So just quickly moving on, I just wanted to call out a few announcements really since our last meetup. So, just thought I'd add this little section in just to give people a little bit of food for thought. But you may have noticed this week actually that the GPT 4.1 model series has been released and it's available in AI Foundry. Just a couple of key features, but it's kind of predicting that there's enhanced coding and instruction following with the new 4.1 models. You can kind of look at them in that kind of standard model, mini model, and nano model, with highest reasoning and accuracy being given to the 4.1 model. With that comes the higher costs, and then work down to mini, where you've got a bit of a balanced reasoning and accuracy and balance cost, with nano then that model being the lower reasoning end and of course the lower cost. So yeah, have a look at that. There's also fine tuning support available for the 4.1 and 4.1 mini is being enabled as well. So you can obviously customize the models to specific business needs. So go and check that out. You should be able to click on those links actually to the blog articles. Next one as well, sticking with the theme of AI, because it's obviously the theme of the decade, so why not, eh? We've got the Llama 4 herd modules that are available in AI Foundry as well. So these are the Llama models that have obviously been developed by Meta, so they're available in AI Foundry. There's actually two different flavors in this kind of model group with Llama 4 Scout. There's a couple of different versions of the model, but looking at the research and just reading a blog article, there's basically various power and precision requirements that you can use the Scout models for, and they try to fit it all onto a single H100 GPU NVIDIA platform, which is quite interesting actually when you start reading through it. Massive context length of about 10 million tokens with the Scout models, so it's kind of like increasing that capability and usage. And you've also got Maverick models. I'm pretty sure they were called Maverick models when I was reading it earlier on. Again, designed for complex problem solving, the dynamic task management, and there's this concept of seamless collaboration between different agents as well. So building into that agentic kind of platform. So take a look, have a read of that blog article. another couple of call outs, something a little bit more close to home from an infra point of view, but Azure Files. The product group have recently released this blog article about Azure Files, getting more performance and more value for your file data. So if you do use Azure Files or want to look into that, read that blog article. But there's a new billing model, so really helps move from this usage-based pricing structure to more of a provisioned offering. So just really about offering you more control and predictability over your storage costs as well. So it's probably worth looking into if you're a heavy user of Azure Files, or certainly working with customers in that. They've done some enhanced performance limits as well. I think they've expanded up to about 256 terabits. I think it is terabytes. IOPS has gone up massively as well, and massive security improvements. So have a little read of that blog article if you are interested. And finally, we've got to get one in, Matt, vibe coding. I mean, it's the talk of the town, right? So for those of you that haven't heard, we've got agent mode has been activated with GitHub Copilot, and I actually did watch quite an interesting demo of this probably last week at some point. So if you or any of your customers are kind of coders using GitHub Copilot at the moment, then it's probably worth checking out this agent mode, because it kind of, I mean, Matt, you probably know a bit more about it than me, but from what I saw, you can kind of do terminal commands. There's analyzing any runtime errors, builds, and give suggestions of automatic fixes and enhancements. Have you managed to have a look at it yet?
No, I mean, this has been on my list of things to play with. I haven't got around to doing it yet. I have used the 4.1 actually. I put it in the chat. I've used that this week, and that's been very good.
Yeah,
the new models in there, but no, I'm excited to try this. I've heard mixed things compared to some of the other tooling that's out there, but I'm intrigued to see. I think it's only a good thing, to be honest.
Just pitching in, because I'd used agent mode this week. One of the things that I find really interesting about agent mode, and where there's like a good differentiator to call out between some of the other kind of GitHub Copilot modes, is that agent mode will iterate over itself. So as you're seeing, it's running terminal commands for you, and then as it's seeing those terminal commands failing, inevitably it will iterate and say, oh, I realize what I've done here, let me try and correct it for you, and then rerun. Usually at that point prompting you to obviously confirm you want to rerun, but really helpful in terms of, like, again, boosting that productivity.
100%. Yeah, I mean, one of the things, like even the 4.1 model now, because I'm working with a few customers, obviously refactoring code from earlier versions of .NET up to kind of .NET 9 and the like, and other languages. But I know there's programs Microsoft has to help customers through that process. But I think knowing that 4.1 now offers that enhanced capability from a coding perspective is quite, well, I mean, when's it going to stop, right? It's going to get better and better, isn't it, fundamentally? So, but yeah, have a look. I mean, to be honest, I think it's free as well. Agent mode has been activated. If you've got, if I remember rightly, I think that you can either, they probably changed it now, but when I was looking at it last week, you could go into insiders mode on VS Code, and you could flick to agent mode, turn it on. So it's worth just having a play. Like I say, I watched the session on it, and like you say, Owain, it was like iterating through its own errors and kind of going, oh yeah, I've messed up, hang on a sec, let me try something. I was like, really? Okay, get it right in the first place. But anyway, so I think that's about it in terms of other announcements. So yeah, a couple of others. We've got Build coming up, so if you're interested, there's usually the digital event if your purse strings don't stretch to flying out to Seattle for Build, but May 19th to the 22nd, usually some really good kind of digital, usually some good digital interaction as well, and they're normally pretty good now in terms of what the in-person events are and making them online available as well. So go and get yourself registered, and be nice to see if you could get out there and fly out to Seattle, and Ignite, save the date for Ignite. It's in San Francisco this year, so gone are the days, I think, of me going and seeing all these high-flying conferences. I think be nice thought, fly out to San Francisco. But save the date, November 17th. Look out for ignite.microsoft.com for further announcements on that as well. Quick call out to our sponsors. As always, big shout out to Servant. If you don't know Servant they are a pure play Azure consultancy practice that obviously specialise in anything there is on an Azure platform to do, migrate and modernise, all that good stuff. Des and the team, fantastic group of people. Go and check them out. They're based up in Glasgow, HQ'd up in Glasgow. Yeah, thank you to Des and the team for supporting this user group and others across the UK since we started. So big shout out to Servant as always. And last shout out to Credit Safe. Did that? Where's that? That's weird. Is that coming up red for you there? That slide then?
Go back one.
Gone the wrong way. Is that? There's no writing on it.
Yeah, there's no writing on it.
I've got writing on my side, but I can see that's weird. So it should say
Weird.
Credit Safe about middle of the screen. That's strange. Okay. Anyway, Credit Safe, HQ down in Cardiff, joined up with us again. It's been probably a good 18 months or so now, Matt, right? You know, the idea being local Welsh businesses, you know, helping build that network of companies for folks to kind of, you know, network and socialize with. So, yeah, big shout out. They've been on the user group a few times, given us a few talks about what, you know, how they're using multi-cloud as it happens. So, yeah, big shout out and thank you to Credit Safe as well. And I think that is me at the end of my ramble. So, yeah, thank you all for joining. I think we will kick things off now with Owain Osbourne-Walsh. And I'll hand over to you, Owain, if you're ready. I say that as you've ducked down and hidden away from me.
Yeah, I was just apologies. I was looking at my my sharing screen. Of course, let me just share my screen quick and get the presentation up.
Bro.
Slide a few slides ahead. Getting a sneak peek. Let me go back quickly. Is that coming through?
Got you. Yeah, over to you. Thank you, sir.
Perfect. Yeah, thank you, John. I think I've got probably about 45 minutes to talk to you guys about something I've been working on recently. Been chatting with a lot of customers, naturally, as John kind of mentioned, theme of the decade, AI. And a slightly different perspective, probably from what you're used to hearing, especially from Microsoft, about how you can run LLMs, how you can create AI-enabled applications. I've got a demo ready at the end of these slides. There's not too many slides. I think there's like 10 or 11. The demo itself was one that I published in a GitHub repo a couple of months ago. For my sins, I haven't gone back and touched it since. I've moved on and then come back to redeploy it, and there's been a couple of changes. So the demo, when I get to it, there's been a couple of changes, and it doesn't run quite as nicely as it did a couple of months ago, and I spent today kind of getting it ready. But it'll be interesting to talk about, you know, or highlight a couple of the things that aren't working, and it will highlight kind of why they're important in this case. So yeah, looking forward to that. And you know, if people do have questions as we're going through it, feel free to put them in the chat. Although I won't be able to see it, but if, you know, John or Matt can come off mute and shout them, or obviously feel free to come off mute and shout yourself. My name is Owain Osbourne-Walsh. I'm a technologist at Microsoft. I work primarily with our kind of cloud native suite of technologies. So heavy into AKS, one of our SMEs in the UK, but also obviously our AI services and data services as well. Today I'm going to be talking about Kubernetes AI toolchain operator, specifically KAITO, but you know, that's more of an implementation detail. To start with, we're kind of going to look at generative AI adoption, look at open source large language models and why you might want to evaluate open source large language models. And that's probably where I'm already slightly deviating from what you usually hear from Microsoft, but definitely not from our stance. You know, you see in AI Foundry and in your AI Hub, if you have it deployed, that, you know, you have available a large suite of open source LLMs to kind of pick from. So it is definitely a route that we support and see as important for our customers in the same way that we do with kind of all open source technology, but probably gets a little bit less attention than ChatGPT or other proprietary models. So with that, we'll jump straight into kind of generative AI adoption and what we see slowing down generative AI adoption. And I'm sure you guys have probably experienced this. But certainly this is something that I've seen with the customers that I work with the, we've got things like getting started and development, and actually customers are starting to kind of get past this one, I think in large part due to just the kind of critical mass of resources, of blog posts, of abstractions of AI and LLM, and even kind of, just more traditional machine learning services that have kind of been bolted on under this new wave of artificial intelligence hype. That getting started in development bit, we're starting to see customers definitely be kind of more capable of moving past. Context, things like RAG have made this a lot easier, but in general, again, still something that definitely enterprises are still trying to figure out, which is, what do we do around data governance? It might not be so much that the large language model doesn't know your data, but it might just be, how do we ensure that it's using the appropriate data? Or often this kind of misnomer, I would say, that large language models enable people to access data that they shouldn't necessarily have access to. It's usually they already have access to it. You use existing access controls, and actually they've had access the whole time. It just surfaces, maybe some access control issues that have been there for a while. Evaluation is definitely something that is still a challenge for customers, but primarily one of the big ones that I talk about with customers, and evaluation kind of comes in, but certainly this last one around operationalization. So concerns around privacy, security, grounding, that's kind of the context piece. Evaluation again, but also this, the kind of buzzword in this space is always path to production. What's the path to production? And this is a really interesting topic, and one that KAITO, Kubernetes, our toolchain operator, looks to help solve, especially when we're looking at custom open source LLMs. But before we kind of jump into KAITO specifically, it's worth touching on why you might want to evaluate an open source large language model versus a proprietary model. There's lots of different reasons. One is possibly avoiding vendor lock-in. I don't know. We'll see how the dust settles on that one, but that in general is a good reason to look at open source technology in general. Certainly things like control and customization, the ability to obviously fine-tune these models, to really, for your data scientists to really be in the weeds of how these models work, and being able to have a much broader selection when you look at the custom open source LLMs, of picking specific SLMs or LLMs for your specific workload or your specific need. A good example of this is always like, large language models that are in different languages, and that could be programming languages, or that could be actual spoken languages. I think a big one, and one that, two of the reasons that I potentially see open source LLMs becoming more popular in the future is security and data residency. The security point is more around being able to, and although we are seeing changes in this already with certain managed AI services being deployed or kind of managed on, with different services now, like the ability to deploy like Azure communication services within a Kubernetes cluster as a container, and then, therefore being able to bring it into your kind of like managed environment. Keeping models and proprietary data isolated is a real challenge when you're using a managed endpoint or managed open source model that's deployed somewhere else. And the same thing obviously goes for data residency. So if there are certain models that are unavailable in certain regions, or if there are concerns around where those managed endpoints are deployed or limitations, then being able to use and deploy a custom open source LLM is really powerful. Obviously, the avoiding vendor lock-in bit then kind of magnifies that, because you may have proprietary models that you're looking to use. When we think about, I think John already mentioned, credit safe being cross-cloud or multi-cloud. Often one of the challenges of being multi-cloud is, well, which tooling do we select to kind of use strategically as an enterprise, try and bring that kind of operational overhead down by having some kind of shared or unified tooling. And again, open source LLMs is a really good way to do that, because you can deploy the same LLM, same fine-tuned LLM potentially, or an LLM with the same kind of RAG architecture in Azure as if you felt compelled to in AWS. I say that as someone who used to work at AWS. And DeepSeek R1 was a really good example of this, right? Where suddenly you had a load of hype about an open source large language model, and if we think about that route to production, going into the development, like going into your development environment and being able to at least play with that open source model, potentially even against your own data, with it, that's something only really possible if you have a vehicle to be able to deploy open source LLMs within your organization. So if we think about the fact that we know we want to deploy large language models, and Steph Locke, who I don't think is here, but is fairly prevalent in Welsh technology circles or Welsh Azure circles, would probably challenge me on this slide, but it's certainly my opinion. It's actually definitely also Microsoft's opinion. But the best, if we know we need to run these open source LLMs, well, where do we want to run them? What's the best platform for AI? What's the best platform for LLMs? What's the best platform for machine learning? My opinion is that it's Kubernetes. Microsoft's opinion is also that it's Kubernetes, given that that's the foundation of all of our services, our managed services, and we just kind of abstract that away from customers, but that's certainly the approach that we take and the conclusion that we've got to. But I suppose then the next question is why? And really, it's the same kind of reasons that other applications are suited for, or Kubernetes suits running other applications. The ability to really rapidly scale out, the ability to create namespace-based isolation for specific workloads or specific models that you're deploying, the ability to run, obviously, containerized deployments, which kind of goes hand in hand with running on Kubernetes, but also now with projects like KubeVirt, the ability to, if you so desired, also manage a VM estate within a Kubernetes cluster, and that's really helpful if you have applications, potentially like a database, or, which I don't encourage you running Kubernetes, by the way, just as a side point, but like a message broker potentially. Again, not something I usually would encourage someone to run within a Kubernetes cluster, but if there wasn't a requirement for the message broker to have long-lived or persistent storage, then, and it was just purely to provide a degree of isolation between services, maybe being able to deploy that within a VM in Kubernetes could be kind of compelling, just for like long-lived connections and those kind of things, because you're not scaling up and down that VM as much as you might be a container. But the idea here is that when we think about running applications in Kubernetes, we think about definitely training models or running fine-tuning jobs. Kubernetes really lends itself for that because of the self-healing architecture, because it acts as an orchestrator of those containers, and because you're able to do things like, definitely when we think, I was at KubeCon this year, there was a really good talk. I was at KubeCon this year, I was at KubeCon last year, so KubeCon is KubeCon EU is usually in March every year, and actually KubeCon last year, there's a really good keynote from NVIDIA that spoke about approaches to GPU splitting, and how you kind of share GPU resources, and AKS kind of, or Kubernetes in general, lends itself really nicely to being able to facilitate things like GPU sharing across different workloads or different training jobs, doing things like MIG or MIP based GPU sharing, even things like time splitting, having that kind of pool of compute resource and having Kubernetes basically orchestrate the jobs that then run on that compute is really powerful. So what is KAITO? As I mentioned at the start, is the Kubernetes AI toolchain operator. And more specifically, KAITO is an open source project that is not specific to AKS. It runs across any Kubernetes distribution, but was released by Microsoft, is almost exclusively at the moment developed and managed by Microsoft, and basically the idea here, as it says here, is to leverage a Kubernetes ecosystem, allowing customers or users to deploy AI tooling as a service, and the operator part of it is really around streamlining that process and making that as easy for users as possible. So looking at the architecture, KAITO essentially looks to handle a lot of the provisioning, creating, and managing of the self-hosted large language model within your cluster as it can. So to start with, if I can find my cursor to get the laser pointer, we have these custom resources. That's what the CR kind of stands for here. We have a LLM workspace, which I'll jump into kind of what that looks like as a custom resource in a couple of slides. But if you just imagine that to be the kind of representation of the large language model that you want to deploy, you have an AI workload, and just for the sake of ease, if we imagine that that's a chatbot, obviously it could be any AI kind of use case, but a chatbot's a nice simple one. And we have a node provisioner here, and again on the next slide I'll jump into what that node provisioner looks like and why that's important. But the point here is that when you run KAITO without having to worry about the creation of a node pool or the scaling of that node pool, all you have to do within this workspace is define the SKU that you want to run your large language model on, add in a couple more parameters, and on the back of that custom resource being created, another custom resource is then created for you, which is this node provisioner, and the node provisioner then goes away, creates these GPU nodes within your Kubernetes cluster, and pulls in the large language model that you specified. And if we think about kind of the time saving there, I mean, in the first place, kind of where would you start, especially if especially if the open source LLM that you want to run doesn't actually support maybe a container image? Where would you start actually running when it comes to like running or deploying a large language model? KAITO looks to make that easy by having this really clear workspace definition that you can just type in YAML, and then handling the provisioning and pulling of those images and setting up of that workspace essentially for you. And that includes everything from training, if you want to go down kind of the fine-tuning route, all the way to inference. So that GPU provisioning point, you'll notice they were kind of individual GPU nodes. These are pre-provisioned and pulled in, and then have the large language model kind of pulled in and loaded onto them. Again, that's because usually these large language models are fairly large in terms of actual size, and we use Carpenter for this. Soon to have a managed add-on. I don't know if people are familiar with Carpenter, but just quickly, it's a slight move away from traditional node pool auto scaling on Kubernetes, where you might scale up and down a node dependent on something basically like pods that are unable to be placed. Carpenter looks to change that by essentially creating single nodes from a SKU that you create and optimizing and dynamically placing workloads onto these nodes as they are basically requested, and to a degree slightly pre-provisioning in terms of node size to be able to support the nodes that you're requesting, but constantly looking to right size and optimize the way that those workflows are being deployed. So instead of paying for, let's say, 5 16 core nodes that actually are only at 20% utilization, if you're running Carpenter nodes, Carpenter will look at the SKUs that you've provided as being supported, again with the same kind of taints and tolerations and labels and selectors that you'd expect in a Kubernetes node. And if it finds a node that is more suitable to kind of bring all of these maybe disparate applications together, that are running on all of these individual nodes at really low util, it will bring them all together into one node, and suddenly from a cost optimization perspective, you're able to obviously save cost, and also customers also quite like it from like a green perspective, because you're able to then say that you're constantly optimizing and not over provisioning lots of different nodes and capacity. So KAITO uses Carpenter, which again is an open source project created by AWS. We'll soon have a managed add-on in AKS to be able to use outside of just kind of AI or LLM related workloads called Node Auto Provisioner, likely to GA at build this year. It's been public preview for the last few months. And Carpenter is used essentially because of the fact that it can then dynamically scale and optimize itself against the list that you provide. And the KAITO team provide the list of SKU. Based on your SKU, it then provides some additional parameters to ensure that that node, when it's created, is fit for purpose to be running large language models. Now, there are lots of options when it comes to kind of how you improve the performance of an open source large language model. Large language models in themselves kind of have these, as I'm sure you guys will have seen when you just go and use a generic large language model, obviously trained on usually a massive data set, billions of parameters. And the challenge with this is obviously they're kind of jacks of all trades, but masters of none as far as specific tasks or activities. And if we think about that in an enterprise setting, usually if you're creating some kind of AI application, you're not creating just a generic huge chatbot. You need to narrow down exactly what you want to do with that what you want that large language model to do or that AI application to do. So I'd be lying if I told you that I understand everything that's on this diagram. What I do understand is that fine tuning is a process that looks to solve that with LLMs in general, but certainly is especially relevant for open source LLMs when you're running them in your own environment, because these are just generic models, and fine tuning is that process of taking a kind of pre-trained model and further training it on a custom data set, for a particular task. The challenge with that is obviously, as we hear fairly considerably, there's like two kind of significant challenges. One is it is very expensive and very time consuming. And also, if anyone's been fortunate enough to speak to any of the kind of PG, who look after any of our AI services, they'll often say that actually when customers start doing full fine tuning of models, they degrade model performance. And one of the reasons for that is because, through training, and again, don't know the intricacies of why this happens within transformers or anything like that, but through that training, you can see something called catastrophic loss, which is where a significant set of the data set is essentially, lost or unavailable, at least from the perspective of the large language model, at the point, post fine tuning. So again, that feeds into that performance degradation. Then we have this, additional, this slightly different approach to fine tuning, which is LoRA, which is a low rank adaptation of large language models, which again, I don't completely understand. There's a paper on LoRA and how it works if you feel compelled to kind of go away and really dig into the weeds. But essentially, LoRA looks to take specific parameters, kind of lowest common denominator parameters, and only train the model against the data set that you provide within that kind of parameter range. And what this does from a performance perspective is essentially minimize the number of parameters that need to be trained by, I think it's something like reduces the number of parameters by up to 10,000 times per parameter within a model. So fairly significant saving. What that means then is that there's less GPU time, it's less expensive to train these models, and it's significantly less likely to have this kind of catastrophic loss. And then you have QLoRA, which is quantized low rank adaptation of large language models, which again, I don't completely understand, but has additional benefits. It requires even less compute because it uses quantized 4-bit transformer, a 4-bit transformer architecture. Now, QLoRA, I really don't get, but it seems to have, again, even further more significant cost savings. And again, there's a paper specifically on QLoRA that jumps into weight quantization and 4NFS and all of this really intricate data sciencey stuff that is really cool, but is way beyond and goes way over my head. So the important things, and the reason I'm talking about this is because KAITO supports out of the box fine tuning of these large language models. using LoRa or QLoRa. And again, when we think about that workspace custom resource that I was talking about earlier, this is an example of what one would look like. And we can see here that we're creating this instance type, or we're passing through this instance type, which is like the SKU, passing through some app labels as you'd expect, kind of within a Kubernetes YAML. And then we're also saying that we want to train this specific 5.3 mini model, and we want to use QLoRa. And the idea here is that you can put an input and train it against a specific data set. And I'll show you guys what that might look like in kind of a real example as part of the demo. But the output here is then another container image that is then pulled in and used and deployed as your inference server. And you can start to see and visualize, or I hope at least start to kind of grasp what KAITO is doing here and the way that that fine tuning works. If we look at the kind of example here of how fine tuning works, when you start a fine tuning workspace, what KAITO goes and does is it creates a job. That job creates a pod. Within the pod, there are 3 different containers. One is the container that goes away to either the local file or the remote file that you've kind of passed through with your Parquet data, and grabs that input data. Then it puts it into this volume. Your container then runs a tuning script that takes this data and just iterates over it and uses LoRa or QLoRa. In this case, we've specified QLoRa to fine tune the model. And there's a sidecar container in this diagram that I'm not quite sure. I can't quite remember what the sidecar container does. Oh, it containerizes then. Obviously, that's the containerization. That's the output at the end. The creation of that image then happens in that final sidecar container, and that's then pushed back up to your container registry, ready for you to pull back down and deploy as an inference server. So I have built a demo that showcases this, and this is part of a blog post that I published in the Microsoft Tech community called Self-Hosted AI Applications on AKS in a Date with KAITO and Copilot. It's a very succinct and catchy title, I know, but you can kind of see an example here. Now, I'm going to show this example because as I mentioned, I've had some challenges picking the demo back up today and redeploying it. And that's actually, it happened yesterday. There were a couple of changes, had to speak with the product group. They put out a quick fix, then that quick fix was reverted this morning. So there's been a few things kind of going on in the background, a couple of things in my control, a couple of things out of my control. The demo today, and the reason I wrote this blog post was because there actually wasn't really a good example of how you do fine tuning of large language models using KAITO. So I wrote this demo and kind of created a really simple Microsoft Store Assistant example. Today it's the fine tuning bit that's actually broken because of a change essentially in the Falcon, which is the large language model that I had used, the way that it handles requests, which again is being kind of hot fixed at the moment by the product group. But I'll be able to show you guys inference as a whole, running an inference server using KAITO, and still show you the example of how you would train the model, and we can look at the kind of fine-tuning workspace still, but it's just not running for the demo. So you can see here just quickly in the screenshot, this is when the model's been fine-tuned, and this is kind of like a nice output. It says, tell me your purpose as an AI agent. It says it's going to help me with Microsoft products. I said, can you give me some information? It says, I can't recommend specific products, but this offers a range, blah, blah, blah. One of the and this looks nice and is really brilliant as an example of being able to really rapidly prototype in a single day deployment of an AI application. But one of the reasons that I think is worth flagging here that it says, I can't recommend specific Microsoft products is obviously because, and this is an example of how quickly we're moving. We've moved to this agentic world. We expect our AI applications to be able to make calls out to either in an agentic framework using tools, or at least being able to call out on like current data sets. And I think one of the challenges if you're using open source large language models is constantly evaluating and bringing in the latest large language model, and then also how you handle RAG. And RAG is actually at the moment not supported in KAITO. And that is a big blocker, if I'm honest, to a lot of our customers in using it for anything past exploratory means. But this is on the roadmap coming soon, expected to GA this year. And again, I think will really change potentially the suitability of KAITO for customers who are looking to take it a step further than just POCs and into an enterprise environment, because suddenly you can most likely forget fine tuning, or at least do some kind of much smaller fine tuning, specifically maybe around your company and the bot's intended purpose. So you move past just, you know, passing in a system prompt, and you fine tune the bot in that way. And then obviously, you know, bring in those RAG, that RAG data. And again, if we think about what that looks like within KAITO, the benefit of that could be that you're running, you know, your large language model really close to suddenly maybe the data sources, because they may be part of a container, or they may be a database that's either running in a cluster or potentially peered within a VNet that a cluster is running in. And suddenly you've got this large language model that has a really low latency, close proximity to your data, being able to make these calls out and obviously integrate that within your application. And then how you fit that within an agentic framework would be kind of really something that would be quite interesting to see what kind of customers do with that going forward. That's the end of the presentation. I will say I think KAITO is a really exciting project. I mentioned this in my blog post that I wrote. I think it's something that is probably slightly ahead of its time. It's definitely in its infancy as far as you know, features, and is, you know, if you go and look in the KAITO repo, is being worked on, developed, releases, pushes every single day. And like I said, I flagged an issue to a developer yesterday. There was a hot fix that went in the same day. Okay, it got reverted, but you know, it shows the amount of effort that's going into KAITO and the amount of attention it's certainly got internally. The reason I say I think it's ahead of its time is because I think that much like many PaaS services, or at least, you know, PaaS, SaaS style services, one of the things that we kind of traditionally see, especially from customers, is that you know, you have new technology come out, and we look as a company, as other companies do, to make it as easy for you guys to start consuming as possible. And when I say you guys, I mean customers or users. And what that means is that usually it's through really highly managed, you know, locked down, usually fairly expensive, just in terms of, like, you know, general cost compared to maybe running it yourself, which, you know, if you just think about the raw infrastructure, usually generally expensive services. And that happens initially, and then we kind of see this kind of pendulum swing back as there's more and more abstraction and more projects that come out, more technology that comes out that makes it easier for customers to bring it into their own domain. You know, that general knowledge gap that is usually there when a new technology kind of explodes gets, you know, that gap gets smaller and smaller and smaller. People have more expertise in-house, and suddenly we see that swing back. And I really think that that's, you know, at the moment, we're definitely in the managed AI, managed large language models world. And if I'm honest, would I recommend that a customer runs KAITO today purely based on the fact that RAG's not supported? Definitely not in production. But as I think KAITO gets more mature, and as I think customers' understanding gets better, the skills and the knowledge is picked up, and people start looking at how they can optimize usage of large language models, I think we might see that kind of swing back towards, well, I want to manage it myself, and actually we have the skills in-house, and actually tools like KAITO make it much easier to bring it into my own domain, as opposed to use this managed endpoint or this managed service. So that's the end of the slides. I'll just close the presentation quickly and share some of the share the demo quickly. I can see that I've just come back out we've still got 10 people here, which I'll take as a win because it means that nobody's left after my Kubernetes and KAITO based rambling. So I'll quickly go through. I hope this is all right for you guys. I can go into windowed view. At the moment, I'm on an ultra wide monitor and sharing the whole screen to kind of flip between the browser and VS Code. But if that's not zoomed in enough, I can jump into a windowed view. But the first thing I want to show is just quickly what we've actually got deployed here at the moment, just because I think people might think this is really complicated or that there's a load of services involved. And actually, all that's actually deployed is an AKS cluster and a container registry. And this is deployed from this repository that I've created called AI in a Day. At the moment, like I said, there's a small bug that means that this won't deploy. It's outside of the powers of myself, but the PG, I think, will fix it in the next week. So if you did want to look at deploying KAITO, maybe wait until next week, and I'm sure this will be back running. But there's a full script, just to call out for what I kind of show here. There's a full script that takes you through the entire deployment and creation of everything from your managed identities that are required to your container registry keys to being able to push the kind of application back up, deploying Nginx, and then deploying a kind of chatbot application just to surface the LLM. God, one of the things I really hate is the default location now for when you're screen sharing of the toolbar right on the top if you're in a browser view and trying to kind of click back and forth. But yeah, so feel free to take a look at the AI in a Day repo. That's just another window of it, but you can see at the moment I've got this Microsoft Store Assistant. Like I said, at the moment this isn't trained, this isn't a fine-tuned model. And if you think back to the PowerPoint image that I showed you where I'd kind of trained it to be quite succinct in its answer, and an example of generation of a file that you would use to train this model is here. So you've got this generate Parquet file, Parquet being the type of file that you need to run to train an LLM. You've got essentially these roles. So this is like a user role saying, what are the latest features of Windows 11? Can you recommend me a Microsoft laptop for gaming? What is Microsoft Azure? And then you give it some examples of a response, and you can see that these are fairly succinct responses. Now, if I say to this LLM, now I say, hello, what is your purpose? You'll know its purpose because I'm still passing in a system prompt. So if I go to the components and I go to the chat window where we're actually making this call, you can see that we're passing this message through. And I'm giving it a system prompt that says, you are a Microsoft AI assistant that helps people find information. Do not deviate from your purpose, blah, blah, blah. So we can still give it, some context as you would with a system prompt in a kind of managed service. But if we then said something like, recommend me or maybe what is Microsoft Azure, given we're in the Welsh Azure user group, you should get a response here. So we've got quite a kind of ugly looking response. It's really spat out a lot of information that we don't really need. We want, when you're interacting with a bot, for the responses to be much more succinct and look a little bit more like what we've given as example here to the answer of what is Microsoft Azure, whereas Microsoft is a cloud platform, but to blah, blah, blah. This is a good example of the benefit of fine tuning, even just from a response formatting perspective. And you can see that this is quite a small file actually that we're kind of fine tuning with, where we're only giving it 5 kind of data points to train itself, but actually the results were pretty impressive. And these 5 points, along with that system prompt that you're obviously passing through every single time, that's quite that was enough in the case of the fine-tuned model to have a fairly comprehensive, or at least kind of passable proof of concept to showcase the ability to run a kind of chatbot application for this specific purpose, based on an open source LLM, in this case Falcon 7B. And if I just show you the example, so this is the Parquet, this is what we're training the data on. We can see that this is the actual request within the application, and we're passing through some parameters here like temperature and max tokens, and the role, so saying that, you know, we're the user when we pass through this request, and then obviously we get a system response. If I show you guys what the template looks like, when we were speaking about being able to pass through that data, the Parquet file is actually, and it won't show it to me, but that generate Parquet, that's just a Python script that creates this Parquet file at the bottom. You know, it's one of those kind of ugly formats that doesn't really display too nicely, but you can see that Parquet file has some kind of readable bits that would display, and we also validate it before we pass it through. But that's then uploaded to this storage blob, and what KAITO looks to do is, you know, I've obviously specified the SKU for my GPU here. I've specified that I want to do some fine tuning. I could, you know, also not do this and just have pure inference with the open source LLM, which is actually what I've got running. But in this case, we're going to do some fine tuning. I'm passing through this Parquet file, which just contains those 5 bits of data. And then there's some additional bits here that just define the chat interaction, essentially, with the way that we want the LLM to interact with a user. But you can see here that the output is basically my, you know, create me an image that you push to my ACR, my container registry, call it my adapter, an ACR secret. And then when it comes to inference, we then pull in that my adapter image. We pass through a strength, which just means the how close we want this, how closely we want this LLM to follow what we've laid out in our chat template and what we've laid out in our training, and then we deploy it. And there's a proxy here that just has some access control stuff for cores, but primarily it's just an Nginx proxy that's just passing through our request, because obviously we're accessing the model through a browser and it's running on a Kubernetes cluster that is not publicly accessible. So we have to obviously expose this through a load balancer. But yeah, I can kind of see I'm getting to time, but this is the blog post in the tech community. It's fairly lengthy. It also talks about my experience using Copilot. This is pre-agent mode for the app development, and how that you know, the experience I had with that, and how I used it. And I think that's kind of that might be interesting for some people who are maybe thinking about you know, especially like John said, like vibe coding's everywhere, and this was certainly vibe coded specifically to showcase how in a day, you know, with KAITO, with Kubernetes, with Copilot, you know, you can build out a proof of concept for a kind of with a fine-tuned open source LLM. You know, you think back 12 months ago, I probably didn't know what half of those words meant, let alone being able to get a demo up and running in a day. And this took slightly more than one continuous day. It was over the span of about 3 days, but about a continuous work day. I think it was probably about 10 total hours of work, obviously split up by meetings and those kind of things. But I think there's some interesting stuff in terms of future work. I mentioned here, I think one of the things that will be interesting, kind of tying back to what I said earlier about KAITO, is when utilizing KAITO, because fundamentally when you use KAITO, all you're paying for is the cost of those GPUs. When that, and obviously being able to scale out, you're still scaling out as much as you need to, as much as your scale out rules will allow you to, or as much as your quotas and your subscriptions will allow you to. When that reaches a point, you know, that it is more cost effective than running maybe a managed service, at what point is that intersect? I think that would be really interesting. There's not really, at least at the time of writing this a couple of months ago, there wasn't any data that had kind of been carried out to look at when large language models ran on IaaS become more efficient than maybe managed, or more cost effective than large language models running on managed endpoints. I also think from a governance and operational standpoint, there are currently some drawbacks to KAITO, so we have to think about identity and authorization and how that works, and I'm sure that'll be something that the team will put a lot of effort into shoring up over the next kind of few months. But also I think that there's a thought here around enterprise adoption of KAITO on AKS, combining that with a self-hosted API gateway on AKS, and what that could basically mean from like a latency and performance perspective of being able to have kind of like a full ecosystem of LLMs, all kind of fronted by a self-hosted API management gateway within a Kubernetes cluster, and then having different applications interacting with different large language models behind the scenes and having that all kind of abstracted away. I think that could be potentially something that would be quite interesting. So yeah, I feel like I've spoken fairly quickly. I wasn't convinced I'd fill the 40 minutes, and I've got to time and not had any interruptions, and I feel like I've kind of whizzed through that in the end. But I hope that was valuable. I hope there were some learnings in there. And if you guys, I'm going to hang around for a little bit. I will have to drop, funnily enough, to speak to the PG. I think in about 3 minutes. But yeah, if you have any questions, Owain Osbourne-Walsh on LinkedIn or owaino@microsoft.com if you want to get direct in contact. And I'll post a link to the blog post as well in the chat, so you guys can have a look at that if you want.
Already done it for you.
Oh, perfect. Thanks, John. Oh, Matt. Thanks,
that was Matt, yeah. No, great stuff. Thanks, Owain. No, it's really, I love watching those deep techie jump into the weeds and figure stuff out kind of sessions. Really, really good. I think, yeah, it's like you say, going to be interesting to see what the uptake of things like this are now over the coming, months with customers and, folks alike. But yeah, you can definitely see the advantages doing it that way, right?
Yeah, 100%. And it's something customers are asking about, like I said, not going into production, but definitely rapid experimentation is a good use case at the moment.
Well, it is. It's just getting the learnings, isn't it, for folks? At the end of the day, we're all learning this as we go, and Kubernetes is one thing, AI is another. Bring them together and run. It's interesting to see where NVIDIA are going with their NIMs as well, and how that potentially plays into this as well with those kind of pre-trained specific domain specific models that NVIDIA are doing as well, because I know they're available on the platform as well, right? So. Definitely,
and a lot of these models as well. I think that AI Foundry does an excellent job, or the team at least who run AI Foundry, as let's say on that DeepSeek point. I think there's a funny kind of DeepSeek was released a day later. It was available on AI Foundry, and we had also sued the team behind DeepSeek. So we're really embracing every part of it. So yeah, funny.
No, well, it's moving along so fast at the moment. We just got to keep up, and we keep hold of our seat tails. But no, honestly, thank you, matey. That's brilliant. Thanks for coming along. We'll let you get off and have your chat with PG now. Thank you again, sir. We'll catch up no doubt over the weeks.
Speak soon.
Cheers, Owain. No, good stuff. Okay, yeah, I tell you what, we will jump straight into our next talk. Colin, if you are ready to go, we'll just jump straight on in, if that's all right with you.
Right. Assuming you can see my screen, give me a nod.
Yep, got it. Good.
I'll get my excuses in first, though. I had a molar removed earlier, so if you see blood sort of pouring out of my face, that's probably the gums. Or if you see me sort of, screaming like a wild man, that's probably the strong painkillers. So bear with me. We'll try and get through this. My name's Colin Chaplin. I'm, infrastructure architect, probably with a little bit of a bent on email, but generally speaking, I describe it as in the weeds, the unsexy bits. So not really the sort of really cool stuff that Owain was talking about there, although I think I'm definitely going to have a play with that because he mentioned Copilot. So what I'm going to use to talk about today, it's a good start, is this. Well, actually, it's not that at all. I just thought that if I didn't say the word Copilot or AI somewhere in the presentation, that John wouldn't invite me. But there's no AI in this at all, I'm afraid. What I want to talk about is using ACS as an SMTP relay for applications. So ACS itself, it's a broad suite of things that allows you to talk to customers with messaging, WhatsApp, voice, SMS, chat. But obviously what I'm interested in is the email functionality. Now, what I want to do is, rather than just an exploration or just replaying you the TechNet pages, let's assume it's a fictional real-world deployment. So what I'm going to talk about is what went well, but to be honest, what I'm probably going to focus on a little bit more is what didn't go so well, or what things I had to learn as I went, because frankly, that's that's interesting. But there's no point in me standing up here saying it was all great and all went perfectly and look how good I am. So what I'm trying to do today is just explain a real world scenario, or what something that could be a real world scenario, the challenges with that. And I'm also hoping that, as I go through this, some of you will sort of nod your head and go, yeah, I recognize those sort of problems. The world is not always perfect. So let's imagine our starting scenario. So what we have, let's say it's a financial services company, but frankly, I think it's quite common across the industry now. We have an on-prem migration to a cloud, so data center exit going to Azure, AWS, GCP. And in this particular case, we also have looking to exit a legacy cloud-based hygiene provider that perhaps has been acquired and perhaps is now charging the customer huge amounts of money. But today, we have an SMTP appliance, email relay server, MTA, call it what you will. That takes connections from application servers on-prem, in Azure, AWS, GCP, doesn't matter where it is. It takes those, and it's essentially an internal open relay. It takes the applications, emails, sends them on to the cloud-based hygiene provider, where that then checks for DLP and then sends it to the customer. I think this is a fairly common model, and probably I could walk into any company and you would see something like this. So we're moving to the cloud, data center exit. What else do we have to consider? So this particular example, it's B2C emails, so not marketing, not spam, but emails that customers genuinely want to receive. And there is a little bit of, IT emailing somebody else in IT to say the batch job is complete and that kind of thing, backup failed, whatever it might be. We're talking about 500,000 emails a day. That could be a little bit higher, a little bit less, but roughly in that sort of magnitude. So it's quite an important, when these are all service-driven emails, not just sort of spammy type ones, that's quite a big number. So this particular solution that we're dealing with, it's grown organically over the years, which is my sort of euphemism for it's a bit of a mess. In this particular case, the from addresses on the application servers, there's no enforcement. So application owners were sending emails from localhost, localhost. They were sending emails from partner email addresses, and they were also sending emails from the old company name that were spun off from 10, 12 years ago. So not really in a good place. Some of these application servers were very old. We have things like Java apps, where they're homemade, homebrew apps, but nobody has the source code. And just to add an extra bit of fuel into the fire, we don't really know what servers are sending the emails, because the servers are hidden behind load balancers, and we don't see the server IP addresses. We only see the IP addresses of the load balancers. And in this particular use case, it was challenging to change that behavior. So that's what we're starting with. We're trying to find ourselves a replacement SMTP relay. So options. Office 365 can quite happily act as an email relay. It's obviously already paid for. So brilliant, it does DLP. Fantastic. Historically, Microsoft were always very vague on how many emails can I send through Office 365 from my application servers. If you prodded and prodded and prodded, you would get an answer out of the product group based on the size of your tenant and the amount of licenses you've got. However, that's a bit of a moot point now, because about 6 months ago, Microsoft started communicating a very clear limit. And essentially, if you've got any more than a trivial amount of emails coming from an application server or a document scanner, Office 365 is not suitable for it. The numbers are very, very low. You can't use it. Then Microsoft announced Office 365 high volume email services. And I thought, fantastic, that sounds just what I want. However, right now, that's just mainly for internal emails as well. So it doesn't suit my use case. So I could have Microsoft Exchange or any other product, frankly, in Azure and just send the emails out straight from Azure. Some Azure subscriptions will explicitly block you sending port 25 traffic out, so that's a problem. But the bigger challenge for me is if we're sending out from Azure, we're obviously using, or almost certainly using, an Azure IP address, and third parties know it's a cloud provider IP address, and they will mark it as a low reputation. So in other words, they will look at these emails arriving and go, could this be spam? And when you're sending 500,000 emails a day, and the customers expect and want these emails, you need to be really confident that they're going to arrive. So any sort of thing that introduces risk into that delivery chain is not something we could actually consider. Now, there's obviously lots of third-party solutions out there. I'm sure some of you will have used SendGrid, Mailgun, Proofpoint. Most of these don't provide DLP, which is a major non-functional requirement in this use case. And also, speaking from a non-technology point of view, any of those were going to be a new supplier. The customer in question is very conservative. It would take them probably 6 months to qualify a new supplier. I had weeks to do this, not 6 months. So realistically, that was not going to fly. So in steps, as recommended by Microsoft, funnily enough, Azure Communication Services. So Microsoft is an existing supplier, no real surprise there. The pricing for ACS is actually very competitive, if not better than some of the competition. So that's encouraging. And it doesn't do DLP, which is obviously a bit of a gap. And it does enforce good security standards, which my particular use case is a bit of a problem too. However, it kind of looks like it might meet most of my requirements. In terms of the architecture, by the way, I spent all the money on Copilot credits, so I don't have a Visio license. So the diagrams are a little bit low rent, but I'm sure you'll get the message. So the architecture is pretty straightforward. What I thought was interesting is the data exists in a region, so not UK South, but UK. And depending on the sort of the governance views of the organization, that might be interesting. And obviously that varies from region to region. But I don't recall ever seeing something that's a region-based as a service. ACS only sends emails. Sorry, it only sends emails. It doesn't receive emails back. So it is purely meant for things sending emails out. And it's very SaaS-like. If you are, for example, a SQL guy, you'll know you've got on-premise SQL, SQL MI, and Azure SQL with sort of shades of sassiness, if you like. ACS is probably towards the sort of the Azure SQL side of things. You pick a subscription, you pick a resource group, you have a quota, you live within that quota, you send emails, you authenticate, it sends the emails. That's it. There's very little to sort of configure or do or size. So from an architecture point of view, it's pretty straightforward, nice and easy to get your head around. So ACS looks like it can do a job for us, but I need to plug the gaps. So the first gap is DLP. I also need this internal open relay. The timescales I've got to achieve this demand that I need to do a really quick, or I need to have the option to do a really quick tactical migration. But going forward, you obviously want to improve that. But where it stands, I need some sort of very quick, rapid ability to execute. So I don't want to require app servers to authenticate, nor do I want app servers to require TLS. We don't have the time, capabilities, or skills to go around several hundred application servers that we don't really know where they are and give them an authentication and make sure they're running TLS 1.2. So the answer and this came as a bit of a surprise to me, having done Exchange for about 20 years, but never touched on-premise now, as in new stuff, for probably about 10, was Exchange 2019. So with Exchange 2019, I can use it to bypass ACS if the recipients are internal. Exchange 2019 gives us DLP, which is similar to DLP in 365. It's not exactly the same, but it's good enough for most use cases. It will capture credit cards, PII, that sort of stuff. We're covered from a licensing point of view, happy days, for user licensing point of view, I should say. And if needs be, I can repoint the existing DNS alias of the SMTP Relay server we have today from the old one to the new one. So that probably plugs my gap in ACS quite nicely. And back to my all expenses spared diagram. We are in Azure, obviously. This customer is in UK South. We're quite content with that. So let's pop an Exchange 2019 server in each availability zone, have it in front of a standard Azure load balancer. So simple thing, but really powerful in terms of this customer is now for free, if you like. Their Exchange servers get all the real IP addresses of the sending servers. So now, when the application server sends an email, the Exchange server can get the IP address of that sending server and figure out exactly what it is. Which is really useful for them to fix things going forward. Exchange 2019 then sends it either to ACS or to Office 365 internal, and of course we're in Azure, so let's use all the Azure principles. So log analytics integrates natively with ACS, as you would expect, but let's also grab the Exchange log files from the Exchange servers here and pull them into Log Analytics 2. So we've got one nice little sort of storage area. So that roughly looks like we should fulfill our requirements for a solution. So enough of the sort of airy-fairy architecture stuff. Let's go build. So I almost didn't put a slide on this because it is pretty obvious, most of it, but either via Terraform, whatever you want, or the Azure portal, we create an ACS instance, and inside that instance you create various sub-instances. So I'm doing email, so I create an email communication service instance. You then add your preferred custom domains. You get all the nice lovely green ticks when you do all the DNS stuff. And if you're anything like me, you sort of press a button and go, why is it not working? There's a little thing that always catches me out where after validating the domain, you have to go back into it and connect it to the ACS. Now, maybe it's just me, but I know this, and I still managed to forget it to the point of once I rather embarrassingly raised a ticket on it and then realized, so maybe it's just a UI, maybe it's me, but there is a little, in my mind, hidden option where you have to connect this domain after you've validated everything. But after you've done that, you have your nice new ECS set up, everything validated. At this point, we can only send 10 emails an hour, and only from the email address do not reply at whatever your custom domain is. So that's less than ideal. So that's what it looks like in the Azure console. We have one email address we can send from and only 10 emails an hour. Probably goes without saying, ACS, it wants all the modern email hygiene features. So it does DKIM, it cryptographically signs parts of the message. It needs SPF, and obviously you need to prove that you own the domains, which is a bit of a challenge for me when I've got application owners sending emails out from root at localhost, because I can't prove I own localhost. A really nice thing is that it uses the Office 365 SPF record. So if your domain is sending email from Office 365 already, you've already got that registered against your email domain, which is really handy because you might have a number of includes, or we'll see another reason later why that really benefits. But a little gotcha is that it insists on a minus all, or not squiggle all, in your SPF record, what that means is you're telling the internet to hard fail anything that doesn't come from an approved host. So probably most email domains are -all already. That's the best practice, but there might be good reasons why you've got a squiggle all. So you're telling the internet, if you get an email from this domain and it's not on the approved list of servers, then it might be okay, it might not. If you're in that scenario, you can't use the domain with ACS. You have to change it to the -all, which could be straightforward, or it could be a project in itself to change that. If you don't know, if you don't have control over what's sending email on your behalf, that could be quite challenging in some organizations. So as I say, when we provision this, we get a single domain, single from address, and a tiny quota of emails. So to increase that quota, we have to raise a ticket, and we have to write a document. I don't mean you go into, it's not like saying I want a new VM and it spins for sort of 20 seconds and pow, your quota is increased. It literally is raise the Microsoft ticket, get given a Word document, which you fill in, state what you're doing, why. So, it's a little bit frustrating because that might take 2 or 3 days. But you can also understand that Microsoft are really hot on spammers and everything like that. So they want to keep their good email reputation. Another little gotcha, that's probably of my own doing. So I said, right, thanks, Microsoft. I want to send 500,000 emails per day. Please, increase my quota to 600,000 for argument's sake. And to which I was told, no. We will only increase your quota to sort of a little bit above where you are just now. So that's challenging for me because I want to go from sending virtually no emails to sending an awful lot in a short period of time. So the workaround there was pretty obvious. I got my PowerShell out and I sent lots and lots of dummy emails. And I went back to Microsoft and said, hey guys, look, I'm now sending 50,000 emails a day. To which they said, well, yes, but you've got a high failure rate. Okay, that's odd. But what I'd actually done is on my PowerShell script, I put a typo of my own email address. So yes, they will raise a quota for you, but they also look at deliverability of what you've got. So don't do something daft like I did and send thousands of emails to the wrong address. But after I pleaded my case and nagged the TAM, we got the quota where it needed to be. So authentication. So whatever you're hooking into, you need to authenticate to ACS. It's fairly straightforward, probably something that you've done before. In ACS, so the sort of overall container for containers, maybe a bad choice of words considering we're just talking about Kubernetes, but the overall ACS instance, we create a role in there with just enough rights. So this is off the Microsoft page. It's fairly self-explanatory. It needs rights to be able to send an email. We create a service principal, and then when we're sending a mail through email, it doesn't natively have a sort of you can't do modern auth or anything like that. So we have a sort of a username to send email that's built from the ACS name, application ID, and the tenant ID with dots or dashes between it. So one of the things that sort of caught me a little bit unawares in terms of this project, where I'm taking a very brownfield site and moving it to the new world, is ACS insists on adding every single email address I want to send from, and also the display names. So I'll show you what I mean by that. So this is, again, the UI where I can add all the email addresses I intend to use, so I know what they are. And I could do this via PowerShell or whatever you want, or through the UI, it doesn't really matter. But the challenge is here, particularly, I have to state the display name. So that's sort of the friendly name that I usually would see in the Outlook client. And the reason that's quite challenging is because quite a lot of mail clients or mail email MTAs don't record the display name as part of the data. So I don't really know. I know SAP server 234 at something.com is sending an email, but I may not know the display name. So just the legwork and trying to figure that out and speak to the right people, not a technical challenge again, but quite and arguably it's cosmetic, but these things are important, especially when you're sending emails to customers. So that was a real sort of drama, and we ended up with 400 or 500 from addresses, so quite a lot of admin work. Now this slide's probably, I could probably rename it as how many sort of bad practices can we do in the one PowerShell script, but just to demonstrate how this hangs together, it is very easy to use. So very simple PowerShell script. Resource name is the name of your ACS instance. App registration is just what I've created earlier. Tenant ID is just the tenant ID. Secret key, don't tell anybody what that is. Of course, if you're doing this for real, you would have that probably in a key vault and use a managed identity, all that good stuff. But for the purposes of what we're doing here, and you can see the last line of PowerShell there where I'm sending the email, I'm sending it from, and the display name, this bit ignored, and then do not reply at chaplin.me.uk. And if you note, there's sort of odd capitalization of the do not reply. So it's as straightforward as that to send an email. And that's what it looks like. So top left is the configuration in ACS, where it says mail from do not reply at chaplin.me.uk. Notice that's sort of capitalized normally, but the display name is do not reply. And when I get the email in my Outlook client, the display name is do not reply. It should be this bit ignored if everything was working as you would reasonably expect it to, but it takes the display name from ACS and it absolutely dispenses with the display name. Although curiously, it does take the, if you look at the email address itself, the do not reply, it takes the funny capitalization that I put into the PowerShell script. So that took me a little while to sort of appreciate that, and that was quite a challenge. So I'll divert a little bit talking about the Exchange config, but I think essentially that PowerShell script there, you take the essence of that and you apply it to any sort of mail server, Exchange, iron port. It works in the same way. In Exchange, I just set up a connector to smtp.azure.com.net. Port 587 has to be TLS, and I give it the username that I've created, sort of forward the three bits, and the password, which is a secret key. One interesting thing I noticed is that ACS will accept email from anywhere, as long as obviously you authenticate, including home broadband. So typically, home broadband IP addresses are not accepted by anybody. Gmail, Office 365. It doesn't matter if you are an Office 365 Exchange admin and you whitelist your home IP address. Office 365 will not accept that email. So if you've got a little home lab and you want to just send an email, that's quite frustrating. However, ACS will accept that email from home broadband IPs. So that's quite useful from a home lab. And if you're sending a handful of emails, it's peanuts really. So logging. So it goes into log analytics, into a few tables, so we can do stuff with that, take it into Sentinel, write alerts in the back of it, all very straightforward. And again, as I said, we've got Exchange in Azure, so let's use data collection rules to pull stuff out of the Exchange servers and into our log analytics workspace. And it was one of these ones you look at and you think, well, that looks quite straightforward, I can do that. And an hour later, you come up with this whole horrible, complicated data collection rule, which seems to work, and I never want to visit it ever again. But it gives us a nice set of logs, everything's in the same place, and your team can take a look at it from there. However, if we were building this thing and we are saying to our email administrators, guess what, we're going to give you this fantastic new cloud-based solution, there's one thing that they will come around and say, you're missing something. I'm trying to fault find why emails are not being delivered, and there's something missing. I wonder if anybody can tell me what it is. So this is essentially the two tables in log analytics that you get. That's about the essence of it. So I get email size, sender, recipient, receiving mail server, all that sort of stuff. But the one thing it doesn't have, which is really frustrating, is subject, which if you're trying to fault find why a particular email hasn't been delivered out of 50 emails sent at roughly the same time by roughly the same person, that's really tricky. So might need to manage some expectations there. It's not a rich tool. Again, if your email administrators have never used KQL to find stuff out, then they're going to have to learn. So just in general, some of the things I saw when this was running, it uses Office 365 infrastructure. And by that, I don't mean your infrastructure. You can't go into your tenant and see the emails being sent through Exchange. But because it's using the generic Office 365 SPF record and all this IPs behind that, from day one, we get a nice, strong reputation. Quite a lot of the other tools like SendGrid, they will talk about when your IP addresses first appears in the internet, start slow and build your reputation up, because people treat new IP addresses in use skeptically. Here, because we're using Office 365, we've got that good reputation already. So with all the challenges and sort of interesting bits and pieces I had, we never had a scenario where there was a report of email not being delivered, put into spam, because we're using the Office 365 reputation. The most startling thing I think I sort of learned was typically a mail server, it's store and forward. It takes an email from somewhere, it might write an X header or something like that to it, then it sends it where it's got to go. That's pretty much what email servers tend to do. However, ACS seems to do an awful lot of validation and even refactoring of that email. So that's something that was quite startling. I'll explain why. I guess one of the good things is it takes out the original headers. So that there is, if you ever look at your email header, hey, some of you might have a more fun than that, but it's my kind of excitement. That's coming from ACS and landing in a separate Azure tenant. Doesn't show me the internal server names and everything else. So that's quite nice. Interesting bug that actually hot off the press, may or may not be fixed. I haven't tested it yet. But if you send an email and the email is split before it gets to ACS, then the recipients that receive the email via ACS will not see the recipients that got it before ACS. So in my example here, somebody is using ACS to send an email to Rita and Bob. Rita is in Office 365, so it gets the email direct. Bob is an external user, so it goes through ACS and out. And you would still expect the two header to say Bob and Rita. That's a bug. And literally just yesterday, I got a note of there's a secret X header I can add, which may fix this issue. Haven't tested it yet, but that was something we only sort of stumbled across after about 2 weeks of it being live, and it was quite an interesting one. So attachments. If you have an application and you have rolled your own MIME encoding, I would be very, very nervous that ACS will accept it. It is massively picky over how attachments are encoded into emails. Similarly, if you have an HTML email and you're doing things like you're encoding the image into the actual HTML email, not referring to an external server, you have an image inside the email, it's really fussy about that as well. So the picture on the right is from a PRTG alert. I'm sure many of you will be familiar with PRTG. This was the first application we relayed through ACS, and ACS rejects it because it's not happy with the format. The product group response is, well, we're checking, we're validating because we want this really strong reputation. We don't want you sending junk. And I can sort of see their argument, but I've never come across this scenario where a mail transfer agent would actually look at my email and go, oh, okay, don't like that. And what actually happens, if ACS determines that isn't right, it will either silently drop the attachment or it'll just reject the email. Neither is particularly good. Obviously, the silently dropping attachment, you can only see that and detect that if you have your Exchange logs in KAITO and in a log analytics workspace, and you've got your ACS logs in log analytics, and write a sort of combined KQL query to sort of get the message size in Exchange, get the message size in ACS, and if they are drastically different, ACS has dropped the attachment. There's no other logging or anything else. Now, I believe the same fix that fixes the other issue is fixing this one. Again, I haven't tested it yet because I literally just got it the other day, but hopefully that closes that one off. In terms of attachment size, 10 meg is the default. 30 meg is the hard limit. Again, you have to request that from the product group. Please increase it to 30 meg. This is why, for most use cases, you shouldn't really be sending 30 meg emails anyway. Quite a few customers, frankly, won't accept emails that big, but that's the limits you have to work with. And I think it's fair to say, I said I would focus on the negatives because there's no value in me just saying everything was brilliant. But equally, I'm talking about incidents out of, and we must have sent hundreds, if not thousands of millions of emails by now. So, these are very selected challenges out of millions and millions of emails being sent without any issues. This was another gotcha. So this is message suppression. So if you are sending an email to a mailbox, that mailbox is full, no longer exists, whatever reason, it's not accepting email, and you try to send another email to that mailbox within 24 hours, ACS will suppress that message. In other words, it will just not try to send it, not give a non-delivery report, it will just suppress it. Now, I can see the rationale for that, especially from a sort of a bulk communications point of view. Why would you bother, continually sending to a mailbox you know isn't going to accept the mail? Other third parties do the same thing. SendGrid does the same thing, although in SendGrid you can choose to turn it off. Why this is a particular challenge in my case was part of the business have an obligation to communicate with the customer. And if they can't communicate with the customer, they would send them a letter. So their operational procedures, they looked at their non-delivery reports, bounces they would get back. The minute they got a second bounce from a customer, they would literally print out a letter, put it in an envelope and send it in the post. Of course, we implemented ACS, which was not bouncing that second email. And all of a sudden, they went from sending maybe 100 letters a day to not sending any. And that was obviously a potential problem. However, it's one of these things where we sort of made a silk purse out of it. Again, the developers here were all Java guys, not familiar with Azure, wouldn't know one end of log analytics for another one. However, there's a nice API there. We were able to point them to the API, gave them service principal with read-only access, and they were able to query log analytics and not just sort of see when mails are failing, see that mails are being delivered. So they went from a sort of a very reactive, unreliable thing where they're looking at non-delivery reports, which are hard to parse. And sometimes it could be in a foreign language. So, if you've got a little bit of code that's trying to parse on a non-delivery report, doesn't work. They've gone from that sort of operation to querying the log analytics through the API, and they get a nice sort of a status of where their emails are. So they've actually got a really nice solution now, although I do wish I had known about that up front. So this is another challenge. Again, this is a don't try this at home. This is not best practice. This is not a good idea. But it was where I landed. So obviously ACS insists that you own the domains. You can prove you own these domains. And I know we've got application owners sending emails out from root at localhost and all manner of crazy things that were not valid. And we went around them all and said, very nicely, please, sir, can you change your from address? And it was getting towards a busy time of the year. Application owners are busy. We're busy selling stuff. Go away. Okay, I've got some hard deadlines as well. There's no functionality in ACS to rewrite from addresses. There's none in the core functionality of Exchange 2019 to rewrite from addresses. You need either a third party or an edge server. But a sneaky little workaround I found was in Exchange, if we create a special contact object, a mail-enabled contact object, I set a from address. So in this case, badcatchall@contoso.com. I set that from address. I then add as additional aliases all these bad email addresses. So you'll see in the sort of right-hand side there, there's my root at localhost. I set them all there. The net effect of that is when it gets to ACS, Exchange will change the from address to be the badcatchall@contoso.com. So it gives me a poor man's address rewriting. Again, I wouldn't recommend it. The right answer is to tell these people, sort your applications out. But sometimes when you've got hard, immovable deadlines and data center closures and contract extensions looming and all that sort of thing, you have to obviously do what's required to keep the customer happy. So, in terms of the rollout of this, so I started by taking the legacy SMTP Relay and reconfiguring it so some of the email domains went to Exchange 2019, then to ACS, then to recipient. The benefit of doing that is just you can test all this stuff until cows come home. Nothing beats a bit of real-world validation. I mean, I can introduce things gradually. It meant that some of the issues that I talked about in the previous slides, it didn't impact everything day one. And it meant, if needs be, I've got an escape route, I can go back and switch the mail going via the old route. And what we also did is speak to our application owners and say, hey guys, you're a diligent application owner. Can you go and test this new SMTP Relay? Make sure you're happy with it. And if you are happy with it, reconfigure your application to use it, please. So, some people did that and tested it. They were happy with it. And finally, dare I say, less application owners were as diligent as I would like, and we were left with an awful lot of people using the old SMTP Relay. So we just did an old-fashioned DNS reconfiguration so that my app servers think they're talking to the old SMTP Relay, but they're actually talking to the new one. So just DNS redirection, and pow, all of a sudden, hundreds of thousands of emails are now going through Exchange 2019 and ACS. Again, in this example, it wasn't just one DNS alias. Again, everything grown up over time. There was a DNS alias probably used in the last migration but 2 that was still in use. So I took advantage of that to gradually, every day, move a DNS alias across for the SMTP Relay onto Exchange 2019, just again to build things up as slowly as possible. I did realize after the fact that if application servers were rigorously enforcing TLS and SMTP, then there would have been an issue because the certificate on the Exchange 2019 servers, it was a SAN certificate, but the start TLS, the thing that email does when it's talking want to go secure, only uses one DNS name, and it wasn't the name on the historical SMTP Relay. But happy days in that use case. Some of the bad configuration that was historical helped me out because they were configured wrongly as well. So I could be quite confident that there was no issues, because there would have been an issue anyway if an application server was really picky about certificate names and things like that. But overall, we met timescales. We did everything. We got out unscathed, and it is working today. And it's behaving itself. I think the biggest takeaway, a thing I didn't really appreciate till after the fact, was using the Office 365 infrastructure is a massive benefit. Nobody else can do that. Nobody else has that advantage. There are other advantages to other third parties, but having the ability to have that really good reputation and that huge amount of infrastructure from day one is a massive benefit. If you are building new applications and sending it and you're using the API, it will just work. Absolutely 100% confident of that. If you have a really unusual mix of things from mainframes to mid-range to Unix servers to things you've never heard of before, you have to be a lot more cautious. So everything I talked about here in terms of doing was about 6 weeks, and that was far too tight. Email, it's not a real-time thing. A web server dies, you're going to know about it pretty quickly. Email, the issues tend to take a few days to bubble up and get passed around various help desk queues, things like that. So doing this in 6 weeks was a little bit too aggressive, but that was the timescales. And again, the technology challenge wasn't there, but getting all these addresses, display names into ACS, that was a tricky and time-consuming task. You used a lot of sort of project management and project admin skills to get there. I think my biggest lesson learned is we sort of went, hey guys, can you just go and change everything across to 2019? Please just go and reconfigure app servers before doing the big bang cutover. With the benefit of hindsight, what we should have done is find our top 20 senders and aggressively go after them to make them change and have their own individual, cutover events, escalating as much as possible or as required to get buy-in to do that. Because at the end of the day, like most businesses, they really need their email. So with the benefit of hindsight, I think I should have gone after and, rather than just relying on the big bang cutover, grabbed our user and said, please change that now. Like I say, ACS is great for API calls, but as a replacement SMTP relay, it does require a little bit of learning. It does things in a rather unique way. If anybody here administers Intune and used to administer like SCCM, and it feels like that sort of change. The people that have built this don't see, I don't think they've got an Exchange background. So it's a little bit of a different culture. And it took me, despite the fact that I've been doing this for 25 years, it took me a long time to really get a feel for the product. That said, it works. It does everything very reliably. It's very, very fast. When I got the quota increased, I couldn't drive it hard enough or fast enough, despite my geeky tries, to send email through it in a way that it would sweat. I would throw tens of thousands of emails at it from a number of machines, and it just delivered them. Pow, 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 pow. And caveats aside, I've talked about in this document, which again is just the small subset of the whole solution. It just works. Once you've got it there, it's fast and it's reliable. So on that note, go forth and send email.
I like it. Brilliant stuff. Great talk, Colin. Thank you very much for that. It's I think you forget from messaging platforms. I mean, I used to work a lot with them back a few years ago, but you forget the intricacies of what's actually involved, don't you? And I think
I just wanted to do sort of a real world sort of, because I speak to lots of different companies,
and
everyone thinks their own infrastructure isn't that great and there's problems with it and it could be done better. But when you go around all the different companies, all organizations like that, there's always stuff that could be done better or challenges or legacy stuff they have to deal with. So I just wanted to expose a little bit of that.
No, it's great. I loved it. I think some of the takeaways, like you say, it's always good to bring out the pain points, because that's the learnings, right? That's the bit that people get tripped up on all the time. But I mentioned at the start of your talk that I'd been working with a customer. I'd not looked into it myself, but the one thing I found quite interesting, I don't know if you came across it, is my particular customer had that issue with reputational sending. They were arguing the case that it was about pen testing an app, so they were trying to send email and make sure it's like, well, actually you only really need to test if it's going to send yes or no, not that you need to send lots of bad email. apparently in the API call, when you send that message, you can programmatically get the output back. It does a test on the email address, so that you can feed that back into your app rather than like email validation in a form on an app. You can actually get real-time information and give it back to your user before they actually send the mail via the API call, which I thought was quite intriguing.
My focus is on just SMTP side of things, quite deliberately.
Exactly.
Again, it's been written, I suspect, written from an API point of view. That's obviously the world we're in. SMTP has been around since early 90s. So it is old-fashioned. You can't do that. Well, you can, but nobody does it anymore because spammers misused it years ago. So you can't pre-validate your emails or anything like that. So the API is much more feature-rich. If I was writing an application, you could use this, get it up and running in an hour quite happily, and it would do a really good job for you.
No, I mean, that was one of the learnings I took from it. It's almost like bridging that gap from the traditional way SMTP would usually work, because again, it was a technical architect that was clearly versed in messaging platforms, but it's like, actually, you can use these APIs now to check before you actually send the thing and lower your reputation, which is quite a great concept. It just shows how these things are kind of moving on. But no, really great. Really enjoyed that. Thank you, Colin. If everybody wants to show their appreciation, that would be fantastic. But if there aren't, I don't think that. Well, to be honest, I think everybody like me was just fixated with your talk, Colin. That was really good. Really enjoyed it. Right. Okay.
I was just going to add, actually, it's one of those great underrated services, actually, and for more than just email as well. Like, communication service has a whole raft of functionality in it, of which email is just one. One of the teams I work with have been doing some stuff in integrating bots as calls into Teams meetings using communication services, and that's really amazing. That's like mind-blowing stuff. But yeah, it's such a good service. It's good to see. It launched with quite a minimal fanfare, and then it's solved a whole load of comms problems. So it's really good.
No, thank you, Colin. Really good stuff. Well, stick around now. We'll mosey on straight into the quiz then. We've not got many people in here tonight, so
we'll do top
we'll
one.
Do top prize. Yeah, we'll have a £25 Amazon voucher for the winner.
Okay, let me just move.
I'll take part as usual, but I normally end up finishing in the top.
Now,
I'll probably get top 10 tonight.
As my caveat for the day, these were generated using GPT-4o, so we'll see how good they are. It wasn't bad, actually. I went back and verified a couple of questions, so we'll have a look at what it's like. And particularly because of the KAITO stuff, I'd never used KAITO before, and I'm certainly going to be looking more into it again. But trying to generate questions about KAITO was a challenge. SMTP, nice. Must be Alan. Guessed it. Called it. You're on mute, John, if you're talking.
I just realised I'm talking away to myself there on mute. Yeah, sorry. Yeah, shout if you're struggling to join. Any more? Is everybody on that wants to be on? A real good chance of winning tonight. It's out of 5.
Yep. Good odds.
What's Alan asking there? Although Colin suggested TLS 1.2, TLS 1.3 for the security bit in your PS.
He's got a line in his PowerShell to set the TLS to 1.2. If he changes it to that or 1.3, it'll use either, depending on what's available.
I did say it was how much bad practice can I fit into the one PowerShell script?
Well, Well, I could give you another one. Instead of doing new object, do the type name with new at the end and the parameters.
I did actually just I did remember to delete the key just before I started this meeting. Otherwise, I bet you would be trying to send.
I got a great new service anyway. Sending my email at the minute, Colin. So
I've just sent 1,000 emails. It works brilliantly.
Should we crack on then?
Yeah, I think so. If yeah, let's go for it, Matt.
So I've got to start with the obligatory AI questions. What new AI model did Microsoft integrate into Azure OpenAI in March 2025?
It hasn't started for me. Is it just me?
Is it not?
Have you not started?
No. I don't know whether we can get you in.
I was there. Let me just technical issue my end. Try again.
It can sometimes take a little bit of time to load the full stack of stuff into your browser.
Yeah.
But if you've got a username bit, it should be all right.
Yeah.
I mean, it's just waiting for the host to start the quiz, apparently.
Yeah. Apologies, Colin. I think you're going to miss out.
Heartbroken now. It's all right. I'm live now.
Which product recently added native support for Azure Confidential Computing? I didn't know this one. I had to go and double check this. Although whether or not it's available in the UK, I don't know. Most of the confidential compute stuff generally isn't, from my experience, unless you go and put in a special request for it. And the correct answer was Azure SQL, apparently. What is KAITO short for?
I think I learned something tonight. I learned a new acronym, Matt.
Yep, I didn't realise it was an acronym until I ran this quiz through. There you go. Everyone knew that one. Great. What's KAITO primarily used for? Although I'm sure blockchain mining is probably viable.
Oh, the thoughts.
Although, does anyone talk about blockchain anymore? Is blockchain dead now? Is that last year's AI?
No, Trump's full behind it, and he's
crypto now, isn't it? It's just your crypto. It's your wallets. It's your crypto. It's your XRP to the moon and all that, right?
So this is a controversial one. What protocol is Azure Communication Services primarily designed for? And I will stick a caveat on this, is that this is not the email part of Communication Services.
Oh.
It's SIP. Apparently, that's what the AI generated. I went and looked it up on the MS Learn docs and found lots of references to SIP. So I was like, okay.
Lots of references to HTTP as well. You would think, or HTTPS anyway.
Well, it's also true.
I'll let them off.
What must be configured to relay emails to Azure Communication Services? And I think, having seen your talk now, I think this may not be right.
Ooh, this is not easy.
Actually, I think I've a bit of one answer, and best answer probably A.
Yeah, it said communication identity. But actually, I guess you could argue DNS as well on that one.
Yeah,
so.
That's why I put it there thinking. But yeah, I can see why you would argue it was A, because it's that's what you need. You don't need. You can use the inbuilt
domain. It has its own domain, doesn't it? If I remember right, yeah.
Surely it still needs DNS though.
No, it has its own DNS name if you need it. Microsoft's 50th birthday. What was our first product?
Ooh. Actually, isn't it none of those?
It was the basic interpreter. Apparently. Because it's just open source. It was Altair Basic, I think, was the original thing.
It was, wasn't it? Off the...
because he's
But
just
did
made
they
it
actually
available.
sell it? Yeah, they didn't.
Clue in the picture.
Oh,
Oh, fucking hell.
do you see his 50th?
And what
50th?
part of fucking Windows did you not get? Is the answer.
You have to tag up the YouTube video now, John.
Developers.
Yeah.
No, it's the Windows one.
Oh yeah, 95.
This month, Microsoft committed to removing how much CO2 by 2037? And this is in tons, I think.
You know, when in doubt, go for the most here.
Metric or imperial?
Oh,
It's
you'd be wrong.
3.7 million tons. What's the name of the AI Windows feature that captures screenshots as memories?
Oh,
And this is for
is that coming
Copilot.
back? I know they
Remote
turned it off.
desktop.
Back, yeah.
Is
yeah,
it
yeah,
back?
they've added it. Yeah, it's in the new Copilot Plus PCs or whatever it is now.
Oh, interesting.
It's Recall. It's been changed slightly, I think, as in what it collects, and I think you have to explicitly.
John, you need to ping them and tell them to call it Arnold.
Oh, yeah, Total Recall.
There we go.
And
Colin
he won
is
anyway.
tonight's
Colin, you
winner.
won anyway. So what? Yeah, God, unbelievable. Right,
Even with
brilliant.
the controversial questions.
Yeah.
Exactly, even with the erroneous, well, arguably, yeah, controversial. Brill. Okay, right, Colin, leave that with me. I've got your email address. We'll get you your voucher over.
Thank you very much.
And well, we'll bring this one to a close then. Let me quickly share up.
Yep, you can have that one back.
Closing part of the deck. And right, let's bring it to close. Right, okay. So thank you everybody for joining. Really appreciate giving up a couple of hours and coming to talk. But more importantly, thank you to both our speakers, Owain and Colin. Yeah, personally, really enjoyed both talks tonight. I think kind of varied content, but I guess that's what we're all about, right? I think we tried to do infra and dev, but we had a bit of a mix up tonight, so that's good. Yeah, huge thanks to our speakers, of course, as always, giving up their personal time to come on and give us a bit of insight into the technology area. So big thanks to Colin and Owain again for that. Next up, we are back on the 21st of May. I think, Matt, you said you're away that day, so I might be...
Yeah, I can't do that one.
Yeah, you've got other priorities. So we've got another 2 speakers lined up as always. So go and save the date. The meetup was announced a little bit earlier today. So go and sign up for that. And yeah, anything to add, Matt? You all good?
No, thank you all once again. It's been a fascinating night again.
Indeed. No, really enjoyed it. So thank you all. And hopefully we will see you all next month again.
So,
cheers all. Bye.
Cheers. Bye-bye.